And when you see the word operations, to you that means I'm going to either be adding, subtracting, multiplying, and dividing. That's what operations are. Addition, subtraction, multiplication, or division. So those are the 4 operations. In 8th grade algebra, we do not need to know how to add and subtract them. We are going to learn how to multiply and divide them. Okay? So that narrows that down a little bit. All right. So this is what your problem is going to look like. You're going to be given 2 whole problems that are identical to the problems that I gave you yesterday. And by itself, you would know what to do with that, right? But then I'm going to ask you to take that and multiply it by this. Okay? Now, we've seen and done something very similar to this before, like off to the side here. If I gave you 4x to the 5th times negative 3x to the 8th, you know what to do with that. You multiplied the coefficients and you added the exponents, right? So you told me that this answer was negative 12x to the 13th. You were done, no negative exponents, call it a day, right? Okay? Well, this is very similar to that, except because you are going to multiply the 8.5 and the 1.7, except they're not coefficients, right? But you're still going to multiply these and add these, okay? That's going to be the shortcut. However, I'm going to just kind of show you that you can get the answer one way. So if you did not know any shortcuts, you might think to yourself, oh, I better put that in standard notation like Mrs. E taught me yesterday. Positive exponent means multiply it by 100, which means move it 2 to the right. That's 850, right? Positive exponent telling me to go 6 to the right, which is the same as multiplying by 1,000,000 with 6 zeros. I'm going to move this 6 places to the right. There's already 1 place, so I need to add how many zeros? 5. 1, 7, and 1, 2, 3, 4, 5. Commas are important. And then could I multiply 850 times 1,700,000? Yeah. Do you want to do that? No, number 1, because your calculator's not going to be big enough to hold it in the first place. So then you're going to be doing that by hand. That way is not really an option for you. You don't want to have to do that. So the important thing is that you could get this answer that way if you took them each, but you don't need to do that because the shortcut is this. You're having you just ignore, because isn't this just a bunch of 1s and 0s? So can't we just, and here's how I equate it. Like if I asked you to do 40 times 50, that's not a good example because it's 20. If I asked you to do 40 times 60, didn't your teacher tell you just pretend like those zeros aren't there and do 4 times 6? And 4 times 6 is 24. And how many zeros did you take off? 2. So add those back in. 2, right? You would be amazed at how many kids I'll see actually set this problem up. And they'll do this, and they'll carry zeros. And I'm like, it's 6 times 4 with 2 zeros, right? So we're going to treat this problem the same way. We're going to multiply these, even though they're not coefficients, and add the exponents. So we're going to just kind of ignore that for now. We're going to do 8.5 times 1.7. And that's going to give me 14.45. And then I know it's going to contain some combination of zeros after that, right? And that is going to be, what do you do when the bases are the same? You keep the base and you add the exponents. Somebody wanted to know why I didn't multiply the 10 times 10 and make it 100. I just told you why. Because it's not a coefficient. It's a base right here, isn't it? If it was 10x to the 6th and 10x to the 2nd, then you would make it 100x to the 8th, right? But these 10s are the bases. And the rule is you keep the base, add the exponents. So guess what? At this point, you have to really read directions closely, because this question is going to ask you to either put it in scientific notation or standard notation. Unless you're me, I'm going to ask you to do it both. But some people might look at that and go, woohoo, I'm done. Scientific notation, I'm good. But if you look a little closer, it's really not in scientific notation, is it? Because the definition of scientific notation, the very first rule I told you yesterday, was that how many numbers can be in front of the decimal? Just one. Only the ones place. Okay? And there's 2. So do you remember that trick I taught you yesterday to get it into scientific notation? So the first thing you're going to do is write it how you need it to be. Meaning I can't have it 14.45. I need it 1.445 times 10. And then you have to put a new exponent. And here's how you walk through that. You said to yourself, I made it smaller, meaning I divided by 10, I moved it 1 to the left, and because I made this smaller, as long as I want to get the same answer, I have to compensate over here by making this 1 bigger. So this is actually going to be a 9. Okay? So the only deal with multiplication is multiply the coefficient, or the actual numbers in front, the constants, and add this right here, just like you did before, right? After that, your answer may or may not be an answer. You may need to take it one step further like we just did. And then, what if they said, write the answer in standard form? You need to get it into scientific notation first so that you can turn around and get it into standard. So now you do what you did on the tan sheet, right? It's always going to come back to that tan sheet. This means take this, move it 9 places over. I already have 3 places available. How many zeros will I need to add? 6, right? So you have to write all of your other non-zero numbers in 1, 2, 3, 4, 5, 6 zeros. So that's going to give you, we need the little kid up here, right? This is what? That's 445 million. So this is 1,445,000,000. Got it? Okay? Yes?
Okay, I need you to explain to me why you moved it to... Never mind.
Okay, no, that's okay, because I know what you're thinking. She's kind of like, well, why did you move it to this just to go to this? Can't you go from this right to this? Yeah. If this question says, what is the answer in standard notation, then you get it from here, and you know what? You move it 8 to the right, and you have your answer. But if the question says, write your answer in scientific notation, it's off. What I'm saying is, if you need it in standard, you can kind of skip that step, right? You can go right from here to an answer. Kayla.
So do you need to ask for standard form? Like, let's say, because at first, before we moved it over, because I remember you have to have 1.
Mm-hmm.
I did because you know how there's 2 places?
Right here, yeah.
No, the 8.5 and 1.7.
Yeah.
Yeah, that'll be 2.
Oh, I'm saying, did you move it to begin with in the problem? No.
No.
Okay, I don't.
It's alright. But
I don't know what you're asking.
I'm saying I subtracted from the 10 to the 6th, and I made 10 to the 4th power.
Okay, but when do we subtract? We subtract when we divide. What are we doing? Multiplying. So you have to add them, which is why your answers were off a little bit. Okay, does that make sense? Okay, let's just do another one so we can kind of get the hang of this here. So let's take 1.3 times 4, hold on, I'm going to get another sheet. 1.3 times 10 to the 5th times 2.48 times 10 to the 3rd. Okay? So you start off with this, and you multiply 1.3 times 2.48, and you get 3.22. And when you get that answer, you go, yes, because it's already set up to be in that one number. You're not going to have to move anything. So you have 3 2/22, and then you add 5 plus 3, right? Because that's what you do with exponents when you're multiplying. So 5 plus 3 is 10 to the 8th. And if the question says, put your answer in scientific notation, you're done. That's your answer. But for today's homework, this is what I'm going to make you do. I want your answer in scientific notation, but then I want you to turn it into standard after that. It's just an extra way of practice. So instead of the 20 problems, I'm only having you do 10, but I'm having you do this extra step. So that's how we're making up for it. So this means positive, move it to the right. 8. You already have 2 places, so I need to add 6 more zeros. And to make my life a little easier to check, make sure I can see your commas, because otherwise it's going to be a big mess and I'm not counting everybody's zeros. Okay? All right. Now, for those people who kind of really did well on their exponent test, this one, let's take 4.3 times 10 to the third and square it. Okay? The same power of a power rule applies here as it did before. 4x to the third squared means square 4 and multiply the 3 and the 2. You know that, right? Doesn't mean 4 times 2. If they wanted you to do 4 times 2, they wouldn't make that too little and up in the air, right? That's what makes it an exponent. So you could say to yourself, I'm going to do 4.3 times 4.3, or just 4.3 squared, and get 18.49. Times 10 to the, do you remember what you do with exponents when it's power of a power? 6. And then, if the answer says standard notation, then just move it 6 to the right and be done. But if it says scientific, it's 1 decimal place off of being in scientific. So this is actually going to be, and then now you have to stop. You really have to say to yourself, okay, you know it's going to either be a 5 or a 7, but this got smaller, so that needs to get bigger, okay? If that confused you, you know what you can do if it's squared? If it's squared, you know what squared means. It means the base times itself. And I just want you to see that 4.3 times 4.3 is that. That's why I squared it. And I want you to see where the 6 comes from. It comes from 3 now plus 3, right? But if you kept it in this form, it would be 3 times 2. But it's still the same answer. Break it down if it's squared if you want to, okay? All right, so are you okay with that? Let's look at this one. Let's take 4.4 times 10 to the third times 1.5 times 10 to the negative 7th. Okay, this is where it's a little weird. So you do 4.4, or 4 and 4 tenths rather, I should say. 4 and 4 tenths times 1 and 5 tenths gives you 6.6. Okay, times 10, and now I have 3 positives, 7 negatives, which gives me 4 negatives. And for the last 2 weeks, I have been beating into your head that negative exponents are evil. You can't have them in your answer. Some of you didn't listen. You just put them on your answers anyway. But so you're not going to have a problem with this. But for those of you who are like, bad, get rid of it, make it positive, guess what? Negative exponents are okay in scientific notation. In fact, it's necessary, right? Because I need this to be negative, because this negative is telling me that, that's going to be a really small number, right? So I don't want to change it to 6.6 times 1 over 10 to the 4th, because does that look like scientific notation to you? No. Scientific notation will never be in fraction form. Don't move that negative exponent. It stays. So did you get that into your head? It's okay to have an answer with a negative exponent in it in scientific notation. Not in any other problems, though. Okay? Are you good with that? So then, if I took it from here to here, now take it from scientific to standard. This exponent tells me move it 4 to the left. I have 1 place, so I need 3 zeros. That is my standard form answer. Okay? All right. Ben.
What if you raise the 4.4 times 10 to the third to the negative power?
Meaning here, yeah. Like if this was a negative second, then you know what you would do? You would take this, just this one, move it down here, and then I love that you just asked that question because then you would have a division problem on your hand, right? So let's learn how to solve division problems. So it's like I planted Ben asked that question. It was the perfect timing. So 1.2 times 10 to the fourth divided by 1.6 times 10 to the negative third. Okay? So instead of multiplying with exponent rules, we're dividing now. And you know what to do? What are you going to do with these two numbers? Divide. And what are you going to do with these two numbers? Subtract. So this is definitely a calculator lesson. You're just going to grab your calculator and figure out what that is. If you're lucky, it'll work out to be something point something. So this right now is 0.75 times 10 to the, take this up here and add it, right? Scientific notation says there has to be a number in front of decimal, and guess what? The number can't be 0. Somebody said there is a number in front of the decimal last hour, and I kind of felt like that's a good question. So I guess it has to be a non-zero number. How's that? Okay? So I really need this to be 7.5 times 10 to the, 6. Because this got bigger, so that needs to get smaller. Okay. So we'll come back to your question in a second, Ben, but I want to ask you this. Somebody said, what would you do if the negative 3 was here and the positive 4 was here? Because so I'm like breaking all the things I had you study and get in your head. You finally just got in your head that you always bring the smaller exponent to the larger, right? So you're tempted to take that negative 3 down there and add it, aren't you? But that's not scientific notation. So here's the rule for scientific notation. I don't care which one's bigger or which one's smaller. I need everything up. Right? Because it needs to be in scientific notation. And is it okay if it turns out to be negative? Yeah. So, against every fiber of your being that I have trained you to do, what do you have to do with that for? You have to bring it up and subtract it, not add it. It's not negative, right? So look what I have up here. When you do scientific notation, you can't have anything dangling down there in that denominator. It's got to be all up, okay? So now look what I did. I have 1.2 divided by this is 0.75 times 10 to the negative 7th. And so what? That's your answer. If I asked you to go into standard form, you would just move this decimal 7 to the left. But what if I wanted in scientific notation? Great problem. Because it needs to be 7.5, and this got bigger, so that needs to get smaller. And what's one smaller than negative 7? Negative 8, right? Okay, so do you see all the little things that are hidden that are going to maybe try to catch you along the way? All right? So, Ben, to answer your question, I really like that because I could give you a problem like that. Ben said if I had 4.3 times 10 to the third, let's say to the fourth, to the negative third, and 6.8 times 10 to the fifth, you would take this and move it and do 4.3 times 10 to the fourth to the positive third. And then what would you do with that? I'm not giving you problems like this. This was just something I know, no, you don't even have to write it. I just know Ben's brain went there and wanted to go further. So then you would take this, and then you would divide this. It's all crazy. So, well, no, we're not going to do problems to that extent, but I know that some people wanted to know that. Okay, so let's have you try this one. 4.3 times 10 to the negative fifth, and divide that by 18.2 times 10 to the negative fourth. I will be nice and do the division problem for you so you don't have to get up and... Yep, like this one. It's easy, guys. Divide and subtract. Except, don't subtract smaller from larger. Always bring it up.
You wanted scientific notation.
I want it both.
Oh,
Okay?
so you're always bringing to the bottom for the
Every time in scientific notation, yes. So, I want you to put it in the answer, then in the correct scientific notation, then in standard form. Standard notation, okay? Go ahead and try that. So I just did that for you. What's that? What'd you say?
Wouldn't that be 10 to the negative first?
Right, I'm just not writing it because I wanted to see if you guys knew it. I was going to let you do it.
Okay.
Yeah, that's the key. So you have to bring... Okay, that starts you off. Then go to correct standard. Bigger here means smaller there. And technically, to go to standard, could you go from either one of these forms to get to standard? Yes. Shouldn't matter which one. Okay? I just like to use the scientific notation one. This means take it 2 to the left. 1, 2. There you go. 1, 2. And here you would only go 1, which is why it matches. Got it? That's it. Okay? It was 20 minutes instead of 15.